When compared to the rest of human history, the amount of knowledge we have about our universe is incredibly vast. We have made so many groundbreaking discoveries about space in the past 50 years alone, from landing on the moon to detecting gravitational waves from galaxies colliding. Yet, as we learn more about the sky above us, it becomes more and more apparent just how little we know about our universe. So many mysteries about space exist, from the conditions that created the Big Bang, to the existence of life elsewhere in the cosmos. Every stone we unturn leaves us with more questions than before, and in turn drives us ever forward in our search for ultimate knowledge. So here are 5 of the biggest space mysteries that we still haven't figured out. Sit back, relax, and enjoy. The Oort Cloud. Comets are some of the most brilliant spectacles that we can observe from Earth. These balls of ice and minerals often have brilliant trails that can be seen by terrestrial observers if such a comet passes close enough to Earth. But have you ever wondered where those comets came from and where they go when they complete their orbit around the Earth? This is a mystery that scientists are still mostly unable to answer. Some comets with shorter orbits closer to our solar system are believed to be from icy interstellar objects called scattered disks. However, this only accounts for a small fraction of known comets. The origins of those with longer period orbits, as well as some short period orbit comets, like the famous Halley's Comet, are not nearly as clear. There is one plausible theory that is thought to be the genesis of all these long period comets. The genesis is known as the Oort Cloud, named after Dutch astronomer Jan Oort. Oort expanded upon and corrected the theories of Estonian astronomer Ernst Öpik, and determined that because of the sheer amount of volatile elements and chemicals that exist on comets, that they had to have formed in some sort of cloud of material on the outer rims of the solar system. The loose gravitational force of the Sun would keep these icy objects in this cloud-like formation. When an object comes close enough to the inner rim of the cloud, it is pulled by the gravity of the Sun towards our solar system, thus getting launched into orbit. Some comets, such as Halley's Comet, get stuck within a close orbit of our solar system, thanks to the happenstance of the gravitational forces, and become short-period orbits of our solar system. Others, such as the Hale-Bopp Comet, can take thousands of years to complete an orbit. All of these objects, and billions and trillions more, exist, supposedly within the Oort Cloud. They theorize this cloud is actually made up of the remnants of the protoplanetary disk that surrounded our Sun until it formed into the planets we have today. Matter that did not get pulled together enough to create planets. Scientists estimate that the Oort Cloud could be 5,000 to 100,000 AU thick, or about a light year in thickness. There's that much space that just has floating ice remnants ready to become comets, if it exists. The big catch here is that scientists have no idea if the Oort Cloud actually exists. On their official NASA website, they refer to the Oort Cloud as scientists' best guess as to where so many comets come from. This cloud is so far from Earth and the rest of our solar system that we currently have no way to detect its presence. The closest satellite we have to the Oort Cloud is Voyager 1, which is currently travelling at nearly 1 million miles per day towards the location of the Oort Cloud. Unfortunately, because of how far the Oort Cloud is, Voyager 1 won't reach the very beginning of it for another 300 years. If it were to try and travel all the way through, it would take approximately 30,000 years to reach the end of the outer cloud. However, we won't ever get to see it get that close, as Voyager 1 will lose power and contact with Earth by 2025, meaning we will have absolutely no way to know what is out past the point we lose contact. Until we find a way to get a satellite to travel far and fast, and that is strong enough to communicate with Earth, we will likely continue to be in the dark about the existence of the Oort Cloud. Signals from deep space. The Earth is constantly being barraged with light radiation from all over the universe. Using radio wave observatories, such as the Very Large Array in New Mexico or Merlin in the United Kingdom, astronomers are constantly studying the sky, listening to these emissions from across the universe. While many wavelengths help us decipher and uncover the universe around us, One immensely powerful type of radio wave emission is almost completely shrouded in mystery. These are known as fast radio bursts, or FRBs for short. FRBs are radio waves that last only a few milliseconds, but that have extremely energetic radio frequencies. These range from 500 MHz up to 7 GHz in energy, or about 500 million times the energy emitted from our own Sun. FRBs originate far away from Earth, with most points of origin being billions of light years away. Because of this massive distance, scientists are unable to identify just what generates these massive signals from deep space. Being able to understand the origins of these massive, far-travelling light waves could unlock incredible secrets and knowledge about our universe. But without methods of detection, we are left completely in the dark. Just what might be causing giant bursts of energy? Many scientists speculate that FRBs have natural origins from high-energy celestial bodies that are far-flung from our own galaxy. FRBs are most frequently observed in singular bursts, meaning that whatever they came from experienced a massive surge in energy that emitted the signal initially. Such an extreme event would theoretically be generated by collisions of massive objects, such as neutron stars colliding with black holes, supernovas, or other neutron stars. Although such a scenario is possible naturally, scientists currently have no way of testing if this is the case, or if something much more complicated and advanced might be at play. Scientists theorize that there could be a constant barrage of FRBs actually hitting our planet every day, but we just don't have the technological instruments to detect them. And we are still learning new things about FRBs every year. In 2015, McGill University graduate student Paul Schultz made the groundbreaking discovery that FRBs could repeat. He pinpointed the signal FRB 121102, which had first been detected in 2012, confirming for the first time that FRBs have the possibility to reoccur. This opened up a world of new possibilities for the origins of FRBs, including some that may involve alien intelligence. Some scientists believe that FRBs could have artificial points of origin, created by a super-intelligent alien species who have figured out how to harness much higher energies than anyone on Earth could control. In March of 2017, scientists from the Harvard University released a theory that said that FRBs might be energy leaks from giant planet-sized transmitters. By creating a powerful solar array 2 times the size of Earth, aliens could harness the power of nearby stars and focus that energy towards huge intergalactic solar sailors. These solar sailors could theoretically carry large numbers of passengers on rapid intergalactic routes to other stars, planets, and potentially even galaxies. It's astonishing to think that FRBs may just be the remnant energy of an intergalactic superhighway. But until astronomers are able to detect precise origins for these signals, we as humans will be left to speculate on this celestial mystery. Dark matter and dark energy. One of the most well-known mysteries of the universe, at least by name, is that of dark matter and dark energy, the most elusive substances in the universe, which we've talked about before. We are only aware of the presence of this phenomena because of their effects on gravity. Otherwise, we have no idea what these two things are at all. Since many people are aware of this mystery, I want to take a second to debunk some of the most common misconceptions about dark matter and dark energy. First and foremost, dark energy and dark matter are not the same thing. Dark matter is all the matter that scientists are unable to detect through current technological means. This includes both baryonic or normal matter that might be difficult for scientists to detect, and non-baryonic matter, which is matter that isn't composed of baryons or atomic particles. However, baryonic matter is thought to make up only a small fraction of what dark matter actually is. Most dark matter is currently completely unobservable and thought to be non-baryonic, as it does not interact with known physical particles and radiation the way baryonic matter is observed to. Many believe this matter is composed of WIMPs, or weakly interacting massive particles. Those are proton-sized particles with extremely dense masses that supposedly hardly interact with any other particles around them, making them difficult to detect. According to astronomical observations, dark matter makes up roughly 72% of the universe. Yet all of this matter is completely undetectable. Dark energy is the supposed energy that has increased the expansion of the universe, and is thought to comprise the majority of our universe, making up approximately 68% of it. Unlike the name might suggest, dark energy is not something tangible like electricity, but more like a force such as gravity. Unlike dark matter, which is a bit better defined, dark energy is only known to be the driver of the accelerating expansion of our universe. In 1998, the Hubble Space Telescope made this observation while observing a supernova from early in the universe's life. Astronomers realized that the universe back then was expanding much slower than it is observed to be expanding today, which at the time was a completely astounding result. It completely contradicts our known natural laws of physics, suggesting that this special type of energy is able to operate outside of those normal bounds, or even that our theory of gravity may be inaccurate. Aside from this information, scientists are almost completely in the dark about the properties or the actual existence of dark energy. Scientists cannot even begin to make headway on what dark energy is, because there is no current way to discern its existence. With so many questions to answer, how are astronomers trying to chip away at the problem of dark energy and dark matter? In the case of dark matter, scientists are trying to utilize groundbreaking detection methods that search for minuscule dense particles. In November 2017, researchers at Brown University unveiled a new experiment for detection that involves utilizing superfluid helium to detect these elusive particles that give off astronomically tiny amounts of energy. If successful, scientists may be able to take their first crack at what exactly makes up dark matter of the universe. Dark energy proves to be more difficult, as it's not necessarily a substance that can be observed. Scientists, at best, can run tests on their theories using calculations and educated speculation. Some believe dark energy to be a kind of fifth element, or quintessence, being a fifth fundamental force alongside strong interaction, weak interaction, gravity, and electromagnetism. Others think the force points to a cosmological constant, as originally theorized by Albert Einstein. Whatever the answer may be, it's rather daunting to comprehend that the universe that we are currently able to see and interact with only accounts for a small 5% of the universe. It makes you appreciate our existence on this earth just a little bit more. Is our universe a simulation? Simulation theory is the idea that our world, or even our entire universe, exists inside of a simulation, and that none of us are truly real. Since its popularization from the movie The Matrix, society has often been fascinated with the possibility that we live inside a simulation. While it may have started out as a science fiction, a multitude of scientific studies have begun to take this question. This endeavour has proved to be rather controversial, as evidence for and against this theory of simulated existence has piled up over the years. So for now, we will lay out what we have learned and leave formulating the answers to you. In the case of our universe being a simulation, scientists have made a number of groundbreaking discoveries that open up the possibility that our universe is in some way simulated by a higher power. In 2012, Professor Silas Bean from the University of Bonn in Germany unearthed the similarities between the properties of a simulation and the properties of particles in our own observed universe. Bean says that Greisen, Zatterspin, Kuzmin cutoff illustrates a fundamental limit on the energy that particles can have, which would have to be the case for simulated particles. With a substantial amount of documentation of this phenomena, Bean believes that this could be a piece in the puzzle for revealing the universe as a simulated environment. On March 7, 2015, a debate was hosted by Neil deGrasse Tyson at the American Museum of Natural History in New York to discuss the possibility of the universe being a simulation. During this debate, Professor James Gates from the University of Maryland presented astounding findings regarding the simulation of the universe. While studying the mathematical equations that make up our current understanding of string theory, Gates found what appeared to be computer codes within these equations. According to Gates, this was a special kind of computer code that corrects errors that happen within computer processing, and are a fundamental part of the code of internet browsers today. The presence of these codes was shocking in the midst of superstring theory equations, because it suggested that within the fabric of our very universe, within the vibrating strings that supposedly regulate it all, there exists computerized codes that keep things in check. Since the discovery of these codes, numerous other studies have unearthed more within string theory mathematical equations. This is some of the most compelling evidence to date that our universe might indeed be a simulation. For the most part, past arguments against the idea that we live in a simulation have mostly been philosophical or metaphysical. This was until October of 2017, when a team of Oxford physicians used quantum physics to suggest otherwise, hailed by some as confirmation that the universe was conclusively not a simulation. Two theoretical physicists attempted to simulate the motion of quantum systems using a method called quantum Monte Carlo. This is essentially a method of simulating complex particle interactions by using random samples of the motions in these systems, since these motions are too minute to simulate directly and exactly. Their experiment found that as more particles were placed into the system, the simulation became increasingly unworkable. So unworkable, in fact, that only a few hundred simulated electrons would have taken the computing power of more than all atoms of the universe combined. Thus, because the computing power needed becomes exponentially greater as particles are added to the simulation, they concluded that the universe could not be simulated. Since the release of this study, many have pointed out that if our world were simulated, we would not be able to necessarily replicate the environment and computing power needed to duplicate such a simulation. One of the physicists himself admitted that the computing power of the universe simulating us could be much more vast than our own universe. So although we have found the bounds of simulations within our own universe, we still do not have the conclusive idea as to whether or not our universe is simulated. And as we crawl deeper into the rabbit hole, we may become less and less certain if we exist in a simulation or not. What do you think? Intergalactic void. Our universe is composed of pockets of energy and space, dictated by the way matter expanded after the Big Bang. Through millions of years, certain areas became extremely dense with baryonic and non-baryonic matter, creating galaxies and galaxy clusters, while other areas become much more devoid of material. It is this natural process of random expansion that has created what are known as cosmic voids. In a cosmic void, matter of any kind is much less densely concentrated than the average area of the universe. The Millennium Simulator, run at the Max Planck Institute of Astrophysics in Germany, provides us with a simulated map of the universe's energy and matter distribution. Paired with studies and observations, one of cosmic background radiation, scientists have been able to discover these supervoids. These voids take up astronomical amounts of space and occupy the majority of the volume of the universe. But what may surprise you is that we in the Milky Way galaxy are living inside the largest supervoid known to science. The KBC void was first discovered in 2013 by astronomers Ryan Keenan, Amy Barger, and Lennox Cowie, thus granting its name. Through further study, the KBC void was observed to be a massive 2 billion light-years in size, larger than any other supervoid observed in our universe so far. This means where we are living right now is particularly devoid of energy compared to most of the rest of the universe. This is an area where even dark matter is relatively absent. But why could that be? Many questions arise about our supervoid that are still completely unexplained. Scientists are still unsure exactly why our region of the universe is so devoid of energy. The matter-power spectrum, as described by physicist Victor T. Toth, gives us a general understanding of how matter ends up distributed less densely in voids, but does nothing to explain the reasons why our cosmic neighbourhood is mostly vacant. It is especially curious that an area so devoid of matter would also be the only known place in the universe for life to have developed. Though maybe this explains why other stars in our cosmic neighbourhood have no signs of life. Are we the loneliest life forms in the universe? It could possibly be so. While questions plague our understanding of our place in the universe, Cosmic voids might end up holding more answers to the secrets of the universe than we ever thought possible. The complete lack of matter throughout the majority of the KBC void makes it much easier to detect when matter actually is present. This means that if we were to try and find some way to detect dark matter in nature, there is almost no better place to be running those kinds of experiments than in our own supervoid. Our supervoid may also help clarify what dark energy is, as we can learn a lot about the way our universe expands by observing the behaviour on the rims of our galactic void. In a universe full of mysteries, it's almost reassuring to know that one of the best ways of finding answers might be starting in the void. So there's 5 mind-blowing space mysteries. Take 5 minutes tonight to go outside, look up to the stars, and question everything about your existence and the existence of this planet. I hope you've enjoyed. Thanks for watching, and I'll see you in the next video.